Taaffe-Hedglin. I'm from Charlotte, North Carolina in the U.S. and I'm an IT architect with the client centers. So what we do is workshops, proof of concepts, and briefings on our products. So I'm going to go through a couple things, which is I'm going to talk about some use cases. I won't spend too much time since we already had a full session on that. But I'll give you some examples of some of the IBM products that we use in the use cases. And then I'll go through some demos of H2o Ai OpenPower and AI Vision OpenPower. So we covered this already. What we're talking about is systems that can see. We have a work with the airports in the U.S., TSA, which identifies weapons in as you go through as passengers. We can hear, we have a project with a railroad track that is listening to the sounds of the locomotives going across the tracks for anomalies. And what they do is they take that sound and switch it into a visual representation of the sound, and are using now deep learning techniques to recognize anomalies. And of course, anything that an expert can do, if you have an expert that does a job that you can mimic through a system, you can then generalize that expertise to many, many people. So we see this a lot in the medical field, where an expert, the top experts will get together to recognize melanomas, for example, and then build a system that new doctors or maybe general physicians who don't have that level of expertise can now use systems that basically provide a subject matter expert in their pocket. So use cases are everywhere. We work with clients across all industries, and earlier you already went through some of that. I want to bring to your attention, since we're in a university here, a couple really breakthrough ideas from universities and industry. This is for the drug discovery industry. The idea is to start with an idea, fail fast, and get to an idea that eventually, through processes, end up with a successful product and something that makes a difference. The idea is, how can we reduce the number of false starts? And we believe artificial intelligence has a lot to contribute here to get to faster drug discovery. And I know there's research in Singapore, especially in this area. Another example that I wanted to bring up is IBM and MIT have a collaboration, and they're working on recognizing motion. And so they have a data set that they've built with over 1 million videos that describe actions. So this, in the future, will be used to augment systems where the hard work of determining what's really happening in a video from an action perspective will have already been done, because we have this large data set that we can build off of. So as I mentioned, across all industries, automotive, we'll go through a couple examples in each of these, and then talk about the IBM ideas. I won't talk about self-driving, but I will talk about this project, which is in April last year, a woman got sucked out of the plane after an engine failure, and it was determined to be very small cracks in the engine blades. So high-resolution vision models is the idea, to see if those can be detected, where you have the opportunity to do better than the human eye in terms of inspections. So that's one idea, and it requires a lot of data and a lot of compute power to get to that point. For security and public safety, we have a lot of work going on, both from the Watson research side of things, as well as some of our video analytics experts, to not only detect facial features and detect people, but also you can see here detecting maybe the mood of somebody entering a retail store, or somebody going through security that looks extremely nervous. So that's the type of applications that we're seeing. And of course on the retail side, we see a lot of examples. Has anyone seen this before? Maybe not, since we don't have too many ladies in the audience. Oil Volet has an app that you basically take a picture of yourself and it'll immediately pinpoint the areas of improvement, the recommendations of products to improve your skin health. And this was actually generated through the employees of Procter & Gamble. They have 50,000 people volunteer their own images and get their own experts determining, the condition of their facial features to build this application. And it's had an incredible success in terms of product placement and sales as a personalized view of selling. This is another example. I'm going to see if we can get the sound going. There's no sound. Anyway, that's okay. Are you familiar with Netflix? Incredible amount of work goes into the experience of logging into Netflix and deciding what to watch next. And this is all about that. It's if you like a specific actor, the little picture of the movie that they recommend will be of a specific actor. If you like a specific type of comedy, for example, the next picture they'll pick to provide an image will be based on that. So when you see Netflix recommendations, they're extremely personalized based on your past viewing experience, based on any information that they have on you that would determine whether you prefer to see a specific actress or a specific scenery, or even what device you're watching this on, because some images look much better on a full screen TV than on a phone. So that's the type of application that,
You're saying that thumbnail gets generated based on your preference?
Yes, yes. So for a single movie, you could have 20 different thumbnails that they pick based on your profile.
And if you pick the wrong movie one time,
That's right.
the movie will show up and you gotta figure out a way to get back into your preferences and delete that thing.
Right.
I don't watch crime movies that kept giving me crime movies.
Don't let your visitors
Yes.
mess with your Netflix profile. You
Exactly.
send them to a different profile, otherwise
They get their own account.
you're stuck with their preferences forever.
That's how it happened.
This happens with my wife all the time. This is my Netflix on my phone.
I don't like this kind of movie.
So industry are, and they're making money. Netflix is, people are dropping, in the US, people are dropping all other services to the advantage of Netflix. So another more serious idea is in retail, but in consumer banking, for example, things are moving from single projects that are a fun and interesting AI idea to a system where systematically all the areas of the bank have reasons to go after AI techniques to solve their issues. So for banking, whether it's fraud detection, risk analysis, credit scoring, they take this to the next level and they're now building entire AI systems with scheduling, with resource sharing. And this is really where you're going from pilot to production, and banking is well ahead of us, and automotive, I would say, is probably the leader because of the self-driving efforts that have been going on. But, and the more we do this, the more we've got crossover between ideas. of, you know, techniques that people are using in one area that are applicable in others. Medical area is a huge example. I think probably many of you have heard of this idea with radiology. Of course, very visual. The advantage here is eye strain for radiologists and the lack of radiologists. This is an enhancement to getting results faster and doing a better job in terms of accurate diagnosis. Same with melanomas. This is an example of an application that was built to detect whether a melanoma needed a second step of to test whether it was benign or atypical. Very few biopsies actually end up being melanomas. So better accuracy up front reduces a lot of stress on patients, when in fact it also could catch things very early and improve the rate of success of surviving a melanoma diagnosis. This is another example of detecting tumor proliferation. And this is more from a computer science AI perspective. Going through the steps, you have to start with good data. This is where the subject matter experts provide the quality data that will then go into your training and tuning. That can take iterations and false starts, restarts, and constantly updating the model. But when you're happy with the result, you can create an inference of that model, which we saw examples of Xilinx. And here the thing of interest is to get to results very, very quickly. And finally you get results. So when we go through some of the examples that I'll do, it'll always be these steps of data prep, modeling, inference. A couple more examples in media, creating headers, but this is a master's, and this is really bad if I can't have sound. But imagine that we're hearing player reactions, crowd noises, and all of these things are being monitored real time and giving this moment a specific rating based on the crowd noises, what they're hearing, and the analysis. So it's text, sound, speech, vision. And what this is used for in marketing is to determine what clip to use next year to promote the event, for example, or how to pay a specific player because they get a better reaction than others, and so on. And finally, in terms of use cases, and especially IBM Research is doing some pretty amazing things with NVIDIA and other partners. And I have a picture of weather, basically, as I promised there would be weather. But there's really some amazing things going on. Peter, who's sitting back there, is also part of our research team, and he can probably articulate even better some of the great things that are going on, like the study of plankton for the health of our oceans, etc. So the IBM research team is really at the forefront of some of these ideas. So let's get back into a little bit of what this means. When we first started this, and with our partners NVIDIA, people were here. They just didn't really necessarily know what machine learning and deep learning could do for them. And we did a lot of joint discovery workshops to kind of generate a vision of what it would be useful for. And now we're finding that people are starting to think about the data that they have, the data that they need, and how to start implementing some of these use cases. And finally, with the example of banking that I gave, it's now a way of life. And industry is really developing their businesses around this. So I'll give you a couple thoughts here. A lot of the data that people analyze today are still spreadsheets, homegrown applications, very rules-based ideas, business rules. And we're at the cusp of disruption here. And I'll give you some things. Forget about Uber. What I meant to say is Grab, apparently, which works extremely well. It's, I can attest to that. Huge company has no assets, really, in terms of taxis, right? Facebook, popular media company, they actually don't create any content. Alibaba has no inventory. Airbnb, largest real estate exchange system, owns no real estate. So these companies are all taking advantage of the digital world and disrupting traditional companies, and are taking this idea that AI can, and personalization in particular for most of these, can really make a difference. So we're seeing that from a data perspective. There's more data than ever before. We've got really breakthrough algorithms, especially in deep learning in the last 10 years, that are continuing to improve the way we do deep learning. And then finally the compute piece with the GPUs that allow that kind of accelerated computing. So I think probably you've all seen things like this before, of how much data is being generated versus, I think earlier somebody was saying that the amount of cameras, only 3% of camera data is being actually analyzed correctly. That's the case in almost every industry. Got a big gap between the data we can collect or we have and the data we understand. So we'll spend a little bit of time on images. This is ImageNet, and this is the algorithm improvement that I was talking about. There was a time where recognizing images was about 70% correct. In the most recent years, in the last couple of years, we've improved human vision. Human vision is around 5%. So these visual systems in particular are actually doing better than humans. Skip this one because it's the same chart you saw before. That was this in this direction, now it's in this direction. Same idea. And we don't need to talk about Moore's Law. We don't need to talk about NVLink because we talked about the big advantage from our systems that we build is we have a very big pipe to communicate from GPU to GPU, but also from CPU to GPU. And this allows us to do things like modeling over larger memory spaces and do large model support. It's a huge business, $31 billion, mostly software and services. And it's not all in the cloud, as some might have you believe. There's a number of companies that are protective of their data and are doing modeling with their own in-house experts and really have no need to go out to the cloud. The flip side of that is having the cloud there is great in terms of delivery models if you can leave your data, if you're secure with your data out there, and especially to get started. So that's why we see so many startups in this space, because they're not necessarily investing in that hard infrastructure on premise. But there's a lot of work still on premise. So we recently are about to rename our Power AI to Watson Machine Learning Community Edition. This is basically open source on Power, but tailored to run easily, to set up easily on Power. So in there we've got Caffe, TensorFlow, PyTorch, SnapML, which is a accelerator out of research, accelerator library for machine learning algorithms like regression. And we've got IBM enhanced versions of Caffe. And basically, the idea here of this community edition is you want to do machine learning on OpenPower, on IBM power systems. You install this and you have everything ready to go for you. In terms of workflow, when you're building these models, you've got data engineers that are preparing your data, as I mentioned before. That quality data up front is critical. And in fact, the idea is to reduce the 80% of the time that's spent here in data preparation with our tools, but a big proportion of time is spent here. You've got data scientists that build and train models. You've got business analysts that evaluate and monetize the models that you build. You've got operations that deploy. This is the inference piece, and it iterates. It iterates. So IBM has a lot of different tools to help this. IBM Watson Studio for data scientists is a very nice way to manage your models and go through the workflow. It supports Jupyter notebooks and Zeppelin notebooks and so on. But I won't show you that. We've got Power AI Enterprise, which is now Watson Machine Learning for accelerators, which is going to help you end-to-end. It's Spark-based. It's going to help you manage all these models, manage your data sets, and do things for advanced data scientists like hyperparameter auto optimization and things like that. And the idea of that product is faster time to results because you're managing your data better, increased resource utilizations because GPUs are fairly expensive commodities, so you want to make sure that if one user is not using it, another user is. So we've got scheduling and resource optimization, simplified management so that you can keep track. And in particular, this is an enterprise solution where you have a lot of different users, and you actually do break up the systems into administrators and users. So it's a nice product, but not really too fun to demo. So what I'm going to focus on is, and this is a chart you've seen earlier this morning. So this, this is the scheduler. That's the deep learning, model management, This is the community edition with all the open source codes ready to go. We have two special areas where we have performance advantages that I'll talk about. And then I'll show you Power AI Vision demo and H2o driverless demo. So these are the two areas that are differentiators. This is called large model support, and basically it lets you do deep learning with higher resolution images, and in such a way that by the time you get that piece of work done with this large model support, it's the equivalent of it takes 4 times less than you would if you had to break it up into smaller chunks. So that's something called large model support. You won't usually see an advantage in most of the benchmarks because they're typically, like the benchmarks we saw earlier today, were 220 by 220 pixel images. These are 10 times by 100 times bigger in terms of pixels. And then the second advantage, and you're from HPC, is anyone else here from the HPC world? So MPI should be no surprise here in terms of how to accelerate things. And distributed deep learning is exactly that, is under the covers, using MPI so that you can take advantage of multiple GPUs across multiple servers. And the nice thing about deep learning workloads is they scale very well. So you can keep going basically with the number of GPUs you need. And that's how Summit and Sierra can take advantage of those 26,000 GPUs for AI workloads. Okay, so let's get started with some examples. And do Power AI first. Okay. Any questions before I do some demo work?
In the process, ma'am, do you have version 1, version 2, version 3 kind of improvement that you establish, or it remains to be just a cycle like that without any kind of?
Yeah. So I think there's a couple questions there. One is all our product development cycles are basically agile based. So every 3 months we come up with new versions, with new features. Sometimes it's performance improvement, sometimes it's new function. Every 3 to 6 months we come up with new things. But the second piece of this is in terms of model management, in terms of versions and all that, the enterprise product, so machine learning for accelerators, is set up to manage that kind of environment where you've got different versions of different models and different data sets, and it's managed for you.
In the R&D process along the journey, do you have oversight, independent oversight, committees or bodies that, overlooking your up and down, good and bad?
Yeah, do you mean internally inside of IBM or
It
with
could be
clients?
inside and
Yeah.
well and outside.
So there's maturity models for AI, very similar to cloud maturity models, where there's checkpoints. Do you have the right data? Do you have all the different pieces, all the different components you need before you move to that next level of expertise? But it's very iterative,
Yeah. Because sometimes the methodology is different.
Yes.
The quantums are different.
Yes.
And so you see, the question is that sometimes you say you go, instead of 2 steps, you go
Yes.
over.
And in a lot of projects, we've actually started with one type of model, be it a vision model or something else, to something different, and realize that would only get you so far, and then you have to revisit different technique. Sometimes even 6 months later, you can read in the literature and find out that there's something more relevant than that.
Because I noticed many of those R&D, they do not test it on the engine capability.
Yeah.
And the worst part, if you go on trying, it's like a sports car, it's all F1, but you have a lousy tire.
Right.
What do you expect to be?
Yeah. The other, in data science, you have to be very rigorous with your data in terms of what you use to train, what you use to validate, which is to update your training, test your training, and then finally what you use to evaluate the true accuracy, the true value of the model. So that's also an iterative process. But yeah, we have a very strict rule. Anytime we get a data set, we put 20% away and don't even let it get onto the system that we use for training, because we want to make sure that it's truly data that the model hasn't seen when we go through. So very iterative for sure. Okay, so this is Power AI Vision. This is basically vision modeling for the non-experts. It takes you through different steps, and at the end, you have a model that you can deploy in other applications as you need. So the first step is create a data set. So here you would create a data set. I picked a video from the Singapore Premier Football League, and I uploaded from YouTube. And I think the delay here is not very good. From this model is I'm going to capture some frames at, say, 10-second intervals. So the idea here is I'm going to create a model that looks at the advertising panels on the side of the stadium to capture how much time each advertiser gets from these highlights that everybody watches. So what I did is I took a highlight video. This is the data I'm going to use to train. I generated automatically a frame every 10 seconds. And for each of those frames, I can, for example, create a category called mitre. I don't know what that is, but that's okay. And I'm going to create by hand a label to recognize this object. Did you see that? And I'm going to do the same for Hyundai, and I think I picked a third one, which was RHG. So I can do this, and by hand, each of these frames, this is too blurry, so I would pick none. And basically determine what, like if I wanted to create a polar category, I would do that. So I did that, and I'll show you the data set I created. So I created a data set that has 32 items. And again, each of these panels has, so this is why labeling, by the way, is so tedious when you have to do deep learning. This is, if you didn't have tools to help you, you would be putting bounding boxes over elements that you want your model to recognize. And here with like slow network, it's extra, extra frustrating. So we'll see if it takes too long, we'll go back. I have to take my word for it. It's, so I created, if you look at this data set, I hand labeled 10 Hyundai signs, 11 Mitre signs, and 17 RHB signs on the panels. From that data set, I trained a little model to recognize those three categories, and I ran it through the data set again and created a new data set that has 141 items. And it basically auto-labeled for me 38, 41, and 68 of these Hyundai, Mitre, and RHB categories. So that gave me enough, not great, but enough labels that I could train a data set with a decent accuracy that it would recognize these in an image of that stadium that it hadn't seen before, or in a video. So you go in and you train the model based on this data set. There are other tools in Power AI Vision that allow you to create more images by creating blurry versions, noisy versions, flipped versions, rotated version. So you can quickly go from 10 to 100 images to 1,000, 2,000, 3,000 images, which makes for better training. So here I'm detecting objects. I'm going to pick faster RCNN, which is pretty much state-of-the-art object detection. I have some advanced options here, which we will pick less epochs. I'm going to leave everything else alone. You can see here my system has 4 GPUs, and I have 2 that are actually running deployed models already, but that should not be a trouble because I'm just going to use 1 GPU. And this is going to start training that model with the 100 images per category to recognize, again, those 3 panels on the system. Oops. Where'd it go? It told me I had too many. I wanted to at least get it to see it start. Okay. So this is the model. This is the trained model. And you can see, even with that few images, it trained to be about 79% accurate. It started pretty bad and then kind of merged in. It did better in some categories than others in terms of recognizing them. And you do have some advanced metrics. But these are really not for data scientists or for statisticians for that matter. This drives them crazy because it's too loose in terms of what it's doing. But it gives you, confusion matrix. So this was the true label versus the predicted label, and it did well in each, and so on. So then you can go in and deploy this model, and it's not letting me because I'm already deployed. So once you get this screen, you can drop images and it'll detect those objects in that image, or you can open a video API, or you can copy this API and use it in a Python script or anywhere else you want to use. So for example, you could use it to count the number of times you get this. This is also where the previous gentleman that was showing the Xilinx example, where you could choose to deploy and create the files you need to put it, to press it on a Xilinx card. So what we'll do, we'll start a video endpoint. And we'll upload a video. And hopefully this will take, I have to say that the speed, the Wi-Fi speed I had was better than in the US in the hotel, so I figured I was in good shape. But here it seems it's taken a little bit longer. That's okay. So anyway, so while that's uploading, it's going to upload the video, and then what we'll do is we'll have it detect the objects we want. And it's going to take a while as well because it'll go through each frame or sample frames and detect those So we'll have to wait for a little bit while that takes place. So while that's going, because this looks like it's taking a long time to upload, we'll go to H2o Ai, which I opened in a different. So has anyone here worked with H2o Ai in the past? It's very, very popular on x86 as well as on Power. It's auto machine learning, and what they've done is they have a team of experts, many of who are competition winners in data science, and all their knowledge about what they would do next and how they would build a model is built into this driverless AI product. Anyone heard of Kaggle competition? Kaggle? I think they have 5 grandmasters that work there, something crazy. So, and in a sense, it's really the same thing as AI vision, but with structured data and regular machine learning data. So I looked for a couple things. I just started one on weather, Singapore weather, to see if things could be predicted, but I'm not too sure about the results yet, so I think I'll start with a simple example, and then we'll see how the Singapore weather one goes. The other data set that I found that was very interesting, that I'm sure some folks here are doing projects with, is NUS tweets. Have you heard of this database? Your school collected 30,000 tweets. I'm assuming student tweets, and posted them publicly without names or anything. But you can do some text research probably, or negative or positive experience, or it's probably a lot of interesting things to do with that data set. All right, so we'll just pick a simple countries of the world. So the first thing that H2o gives you is some statistics about your data set. Forever. System's gone. There we go. Let's go. Maybe I should stop the other one, huh? See how that's going.
No, your Wi-Fi.
And my Wi-Fi is gone. Well,
Is it your Wi-Fi or,
See your message.
is
it your Wi-Fi or, hotspot or college
It's
Wi-Fi?
NUS guest,
I don't think any of us guess you should take it.
not recommended.
Yeah, they didn't allow us to use that too.
1,000 people in it right
Yeah, probably. Oh, upload error, so it's never gonna get. All right, well.
And your risk is moving very fast.
now. Anything that says guess.
Guest is problematic. All right, well. Let's go back to H2o Ai, because at least now this one's working. Okay, so this is countries of the world. Singapore's in there. By region, population, square mile, and we're going to try to predict GDP per capita based on these other characteristics: coastline, migration, infant mortality, and so on. So that's the data set. You can look, H2o also provides a lot of visualization tools. And this is where statisticians are happier. Correlation graphs, move things around to see things better. Parallel coordinate plots. Work your way through. Just some nice things that you don't have to worry too hard about because it does it for you automatically. Radar plot. And heat maps. And for each one of these, H2o gives you a little hint. If you don't know what the graph does, very, very nice documentation. Okay, so let's get ready to start our experiment. So we pick our data set. We're going to predict. If this is your first time, you can get a little tour of what everything is. Here's our target column. We're going to select our target column. We're going to select GDP per capita. These are the knobs that H2o provides in terms of accuracy, time, and interpretability. For each combination of these, it'll tell you what it's planning to do. So again, it's good to have some background so that you understand what XGBoost means and so on. But it's very well tailored to let you try things. So here maybe we don't care about being too accurate, and maybe change explainability also to something lower. Oops. That. You can go to expert settings and it'll give you more options on how to set up your experiment. It's doing deep learning for text analysis. We'll just stick with default, and then we'll launch the experiment. It'll tell you how far along it's going. It's just kicking off. You'll have the option to stop it if you don't want it to keep going forever. It'll remind you what we're looking for, what we're trying to predict. And here, once it gets started, it'll tell you what variables in our spreadsheet, which are what features, meaning what columns, are relevant to the models that they're coming up with. So what's happening in the background is it's preparing to run a lot of different models to come up with the best analysis. And in fact, it'll do feature engineering for you by taking combinations of columns of features that you provided. And it's all going to do this automatically. So give it another little bit to kick off. So this is running on, actually this is a Firestone. It's not, the other one was a AC922, but this system is actually a smaller system. It's giving me some notifications about my data not being perfect and what corrections it's going to make. And here, even with just 1 or 2 experiments, it's telling you how far along it's going. It's already starting to hone in on region and climate and agriculture as being potential GDP per person drivers. So we'll get rid of our notification here so you can see a little bit more. So it's running through a whole bunch of different models. It's looking for actual versus predicted. It's starting to tell you each of these has a specific data point. You can look at GPU usage, which so far not using any. Which I don't remember. I didn't say any. All right, and then here you can look at different experiments as it's going through. So region seems to be the top predictor of GDP per capita, but climate and agriculture continue to be second. So this is not going to take 10 times longer. At some point, it's going to jump pretty quick to, 70% complete. So we'll see. Any questions on H2o Ai while we're here? Okay. This is normally where I jump to the other one to see how we're doing, but since I don't think I can upload that test video, I think we're just going to have to give up. Anyone have any other questions on AI vision?
But yours is on the basis of the context of data and cognitive nature. But you have a separate one where each one by itself, for example, like Google, when they're doing migration from penguin to panda to hummingbird, eventually to AI. But the result is just as worse. It's just they're lucky that there's no contender. Because Microsoft and the others are half-hearted guys. So real competition is not there. So they are, one-eyed jag is the king.
Yeah.
So does IBM do that kind of cross comparison where you see some big company, a great competitor, are taking something which actually is not bringing any result worthy of that exclamation, whatever not.
Yeah, our approach has really been client-centric. So we work with clients to see where their pain points are. And we're honest with them on whether AI is the right solution. When we do, it's called design thinking, with clients, we talk about from their user's perspective, what are the pain points, what are they trying to solve. We will then look at all those pain points and try to match it with AI solutions. But sometimes it's not really AI, or it is, but maybe it's just a simple chat bot, as opposed to, you bring in a whole team of data scientists to solve your problems. So that's kind of how we look at it. So we don't necessarily do direct competitive analysis against competitors. We work with clients and
But actually they are not competitive because they happen to be on different parameters. But in the context of the AI dimension, because when they totally migrated from the old manual system, they're using a lot of Indians, data scientists, and they drop all those things and go absolutely on AI. And completely, you don't see any result that differ completely because it is very much remain to be a keyword.
Technology here is still very much brute force, that the system can't learn what you're not giving it to learn at this point. That's why the labeling piece is so important. Okay, so now we're still going through more experiments, and you can see now region is still number one in terms of predictor, and agriculture and climate have dropped a little bit. So that's what I meant about going from 60% to 100%, just like that. So it's going to finish. I don't think it ever ended up using the GPU in this case, based on how you, depending on what systems you select, it'll either determine it needs it or not. And then it will give you some options to go into alternate models that are used to explain. This is where explainable AI comes in. So for any experiment, you can select as soon as this gets to 100% complete. It'll give you a choice to interpret the model, try another data set. So here it gives you a report. You can download all of this into a very nice report. So if you don't like writing reports about your experiments, H2o Ai is another, that's another plus. And you can go and select, interpret this model. It'll go pretty quickly, I hope. And it will give you alternative models, especially like decision trees, that you can see how to justify any given decision point on the model. So we'll go to that.
But when you're doing such, in context of security, are you able to convert the invisibility to visibility on the TI, the threat, intelligence? Similarly, with this, your capability, how dynamic is your indexes actually capability?
Yeah, I mean, in terms, are you talking about data security?
Yeah.
So this is all done on-prem. So the data security is whatever the administrators and the policies are for data security. So this tool is running on the power system inside the data center. So we're not looking at security from that perspective, other than what's built in because you're on an on-prem environment. If you're on the cloud, it would be whatever agreements you have from that perspective. Are you asking about personal identification? Because that's a whole different set of. So by the time the data comes to us, we've stripped out identifiers, specific IP addresses, specific names, balances, social. Like when we work with banks, we don't see real data; we see similar data.
In other words, you assess those things. The policy-wise, IBM, those is highly 100% defensive, or you have other than defensive capability? Because you know why? The X factor that is the law provides you, enlighten you and protect you from using other than just 100% solely defensive security strategy. So do you practice more than just entirely 100% defensive strategy?
Well, it depends on what, where you're talking about, where the security, we have security products and security policies at every step of the way. So it could be perimeter, it could be within the systems, it could be cryptography. It's security policy is end to end, and we do full analysis of that. So within there is defensive and proactive policies. But mostly it's policies that are implemented, not just automatic. It has to be thought through.
And your quarantine capability is also very good.
Warren?
Quarantine capability.
Oh, quarantine.
Because you need a timeline.
I'm not a security expert. I'm
Yeah.
assuming the security people would know how to answer that, whether quarantine is part of it. Okay, so this is, actually we'll go to the dashboard. That's the easiest. So explainable AI, very important. So it basically looks at different models to justify the decision that your model made. And so here you can see the decision tree was region, death rate, and then based on that, whether it was coastline versus the coastline ratio for some reason. So that was that. And here you can see region, death rate, agriculture, service, literacy, all being the primary features important for GDP per person. And again, for each one of these, you're going to get an explanation of what you're looking at. So this is really good to start for new data scientists and for folks that just want to see the results quickly. So I think that's the end of the demo. I would love to show you more of that AI vision, but I think because of the networking, we're probably stuck a little bit as far as trying a lot of different things. Any questions for me? Yes.
H2o AI is running on your on-premise, right?
Yes.
Is it available on Bluemix?
H2 is not available on Bluemix, other than, actually, yes, Bluemix, so Bluemix is now IBM Cloud, and you can get a power image on Nimbix, and I believe Nimbix has H2O images, so it's a little convoluted, but it's there. You can also get 30-day license for H2O driverless AI, and I believe they have an academic program as well.
Yeah, they have a free
Try.
academic program too. Like, our Power AI Vision is also free for academic users. Are you from academia? Oh.
Yes, Nimbix has H2o.
Yeah, we do give demo through industry. H2o Ai.
43 cents an hour.
You're not, that's the version without the GPU.
That is then, not listed, right?
That's it, that's it.
Yeah, it's really supposed to be.
It's time is money, right? All right.
Yeah.
So-
Great, man, you've been honest.